Hi, my name is Nisha. I'm an open source engineer at VMware. I'm not selling anything today. I just want to have a conversation about build manifests, specifically for containers. So I've been in DevOps for 5 years now, and containers and Docker is fairly new to me. I started off with Docker by using it to make isolated development environments. And this is when I came across the issue of build reproducibility for Docker containers. It so happens that if at one point when I have it working, I'll send it off to a developer, and then if the developer comes back and says, I need a new version of this particular library, and I try to update it, and the whole thing blows up in my face. I am not sure if it is because I'm not doing it right, but I've had many conversations with other developers and DevOps engineers. I don't know, I can't make out the difference anymore in the cloud native space. So the answer I usually get is, who cares? Just build another one. And I really want to find out from the community if this is really the case. Okay. This is, yay, okay. I can now say that I'm not selling anything. except for the one thing. So I'm the maintainer of Turn. It's one of the projects, if you've been at the keynote, that was one of the projects that got donated by VMware to Linux Foundation.
It was coming in for a second there.
And so, 4 years, okay, fine. 4, 5. So I really want to find out if there is something that I am missing over here, or if this is something that is really an issue that other people are seeing as well. So I want to start off by asking, do we actually need a declarative container build? Does anyone have an opinion? Do we need it? Yes. Yes? So we will talk about tools later. I have a list of things, a list of projects that I've looked at, and I'm looking for other projects that need or come close, but I want to step back for a minute and just talk about requirements. So it seems like everyone says we need declarative container builds, and we don't have any of that. Is that a fair consensus? Or okay. Like some people, yeah, okay. And so I'm going to skip this thing. I'm going to talk about requirements. Let me see if I can share this. I mean, the slideshow. So I've listed a list of requirements over here, but I want some input from y'all, whether this is an accurate thing or not. One of the things that I've noticed with regards to building containers is that typically the tools start from starting like a base operating system, like a container operating system. There's a philosophy with containers that goes something like this. The container needs to be built from the app down. So whatever is in the container is only what is needed to make the app run. But the problem with that is that you also need to keep track of what all these things are. And that includes the OS that it's running on. So, for example, things like BuildKit will start off with the base OS. That's, if you look at what it's doing, it will pull an Alpine OS from Docker Hub and will build on top of that. It's not really very declarative because, again, you start from a base and you have no idea of what that base is. So you can replace the Alpine one with a Golang one, and you have no idea whether, what's inside that Golang initial container. So so that's why I want to step back and ask, okay, suppose we were building from like a bill of materials or a manifest, what would that manifest contain? Just like at a high level, we're not talking about rules anymore. So we're talking requirements. So what do we need? Yes, sir. Yes. So I want to step one more level back and just talk about app and dependencies. Because that other container that you're dependent on is actually an artifact of the way that containers are built, which is the deduplication of a base container. So that container that you're dependent on, must that also follow all of these requirements? Okay, I'll repeat what you said. So,
whenever you have multiple containers doing different tasks on the same product,
yeah.
if you take the latest on my backup, it would not do a backup on.
Yeah, so right now the way I feel that the container builds are created is that they conflate build reproducibility and updates. It's like it comes all in one, when in fact it should actually be divided into two steps. So you build it, and if you need update, you take that build and you update that build. And then you keep track of just the updates from the base build. And the problem with the way that we have our container build ecosystem right now is that there is no accountability on the base build. So in any case, that base container is made up of a bunch of packages, yes? So if we are imagining keeping track of what exactly we are building on top of, would you say that that also applies to that container that you're dependent on? Okay, so would all of these things fall under that? Does anyone have any other things to add to that? This is like off the top of my head, and pretend that I don't know anything. Yes?
So you list Tarball. That seems very generic. What are you including in that?
That's a good question. What are you including in that?
Right. It's like I can see, if there's like packages to depend on, like that's something that you should put out. I don't know how those packages get there. So obviously, like either your source code if you're building in the container, or your built artifacts if you're building outside the container.
Yeah. So when someone says tarball, the tarball can mean anything. It can contain anything, which is why it's under like inputs. So would that be like a bundle of files, a collection of files? Can I like abstract tarball into collection of files? I can do that.
I don't know if it makes sense to call out different kind of like files you want to put in.
Yeah, so you're right, there are like source files and there are binary files.
It's like the first-party dependencies that treat differently than maybe your.
I went back. Okay, I'm ending this. So I can come back and edit. Okay. So right here, not tarball, but maybe file system. Maybe one is like source code, and the other one could be binaries or inputs and outputs of a build. Okay. So that's where I'm trying to abstract all of these requirements out, because there's the unit of the build, which is the collection of files. You send a collection of files into your build. You send environments, you send like other metadata into your build, and then what comes out is another collection of files with the same metadata, maybe some extra metadata that comes, which is like, okay, the results of the build. So it's after you abstract everything out like that for that unit of your build, and then you can start thinking about dependencies. Okay, now I have a unit of build that has all of these requirements. I can actually plug in some other method of figuring out what my dependencies are. I mean, this is typically how package management works. You start from the unit of the build, and then you have a tool that does all the manipulation to give you, either your snapshot manifest of the build or your build status or artifacts that you will ship out to someone else. Okay, I'm done talking now. Does anyone have anything else? So I've added some extra stuff over here, which is license compliance, regulatory compliance, export controls, things that may not be something that regular developers care about, but definitely something organizations who are shipping software care about. Yes, sir?
So in your inputs, obviously there's some sort of process that is creating the tarball, and a lot of times you might want to actually include a link to say the job that actually built the tarball, so you can actually trace back to see what was actually happening in that particular job. So even if it's like URL of a build job that created the tarball.
Yeah, so would that fall under metadata, or would that be something that is like lesser than metadata?
I mean, it's eventually, ultimately it's traceable if you have the SCN tag.
You can go back, right? So the idea of the metadata is for traceability, that you can say, okay, I have this bundle of files over here. I can find out exactly like their provenance and what they contain and what was the status when they finally came out at the other end. Okay, I guess we can move on. Let's talk about tools. Sorry. That's a good one. Would that fall under environment variables? Or good.
So it might be good to, so I've heard a couple of things that are like really runtime dependencies.
Yeah. You're right.
Time dependencies, so there's probably build time credentials and then also runtime credentials that you might require for running it.
That's a
About really that runtime requirements for the containers, so like it might be good to divide between those two.
So these are like runtime environment variables and runtime credentials.
Yeah.
That's
Credentials and authorizations would be an info of some kind, but not an environment variable.
right.
Are these all for good builds or bad builds as well? Something like you could not build. Is build log part of this?
So build log may or may not be part of it. I wanna understand why you would think build log might be part of this. Is it just information about the build?
It's like, I mean, this time it didn't build.
I tend to think that it might fall under just build logs if there was a build failure. I think what we're trying to end up in the other end is just after everything is done and you've distributed it, what is all the information that some other person who gets their hands on it will be able to find out about this. So maybe like, the build number or the build date, that could be like an additional metadata that you can add. At the back? So I tried to get it to work, but it doesn't work. So I'm gonna like try and repeat. So there we go. Oh, it works.
It's very hard for
Oh, thank you. So there's a person at the back.
So I was just going to say, sorry, would it maybe be helpful to enumerate what pieces of metadata that we're talking about? I think kind of the goal that we're going for is how to establish trust here, right? So I think there are certain pieces of metadata, maybe some sort of cryptographic, an identity of what is this binary, just to help us enumerate the trust in the end. I'm not quite sure what that would be.
How about if I get rid of just metadata for outputs and put that in its own thing? And then what I've heard so far is that there's like metadata that you add at your inputs and metadata that you add at your outputs. And one of the metadata that possibly could be at the outputs is the build number. I don't think credentials should be part of this metadata. That seems to be more just inputs to the build. That doesn't really go into, I don't think that should go into like a package other than maybe a checksum. So
It could affect the scope or it could affect the space at which it was built. So it has an somewhere. I know the credentials shouldn't, like any secrets shouldn't, but if it was doing a build and accessing data under a certain authorization, and you got like permission denied at some point and you didn't know why, that could affect that. And investigating why a build, the outputs of a build, why it had access to a certain package and not another package. Oh, well, the token it was given didn't have access to that repo.
So
it would be part of figuring out the nature of how the build resulted like it did, but no secrets.
right, would permissions fall under this? Permissions?
Sure. I mean, like that's largely what you'd be trying to investigate in a problem like that.
Typically, when I think about this, I think of just file permissions. I'm not sure. Go ahead.
Results of tests could be potential metadata for a container.
Do you think that would be useful for, that seems more useful for DevOps, but maybe not for the end user? I'll put that in. Okay. No, I understand that. So that's in there.
So I may be slightly biased, but this falls exactly where my research thesis is going on. I'm a PhD student at NYU.
Cool.
I work on the Intoda project, which is a build artifact provenance system for whole supply chain provenance and auditability. We pretty much did this exercise, and we ended up with 4 groups that are not as overloaded in other, like as all of the computing terminology that we have, and it's pretty much materials, which is what comes in. We have products, which is what comes out. Then you have an environment, which is where did it happen. And then you finally have a byproduct, which is, for example, a build log, or the return value, or the standard error, or standard output, which is not entirely an artifact in terms that it can be enforced in provenance aspects of it, but you can inspect it, which
Right,
is probably
so-
something you want to put in like an admission controller, or want to probably later check if the tests all passed and there were no warnings in the text, and so on and so forth.
Okay. No, I understand that. There's something called pre-production, and then there's something called production, and definitely like the byproducts seem to be something that falls under pre-production. You can inspect it and see if everything is kosher.
Exactly.
Yeah. Okay, I've spent a good bit of time on this. I'll move on to tools that I've found that meet or come close, and I'm hoping to get input if there are other tools here. I did So I did start off with Docker because that's the most ubiquitous tool out there. Let me see if I can show the whole thing. Okay, screen. Okay, so I've got a list over here. Honestly, the one that I seem to be thinking that it kind of comes close to what we're looking for is Habitat. Habitat is a tool made by Chef, and someone's already gone. Oh, cool, yeah. Yes.
What do you mean by no dependencies on BuildKit is basically a dependency graph that gets executed. So when you say there's no dependencies, what do you mean by that?
So it means that no dependencies on the base OS is what I'm looking at. So there's this thing called reproducible base image. The thing with the reproducible base image is that whatever you pull from Docker Hub may or may not be the one that you pulled like a few days ago or a few months ago, because those tags are not guaranteed to be immutable.
But you can just reference it with a digest, and then it is guaranteed to be immutable. So, like I'm having trouble with this part of the claim.
Okay, if you can pull a container image using the digest, I don't know if BuildKit does that or not. So this is just something that I've noticed, and it may be wrong. So if you can pull from a digest using BuildKit, then maybe that's fine. Is there a way to account for the base image that you pull from the digest? How do they do that?
Most of it's part of the registry API, and or now the OCI distribution spec. But still, that when you're fetching it, if you fetch it just by name, it implies latest. If you fetch it by name tag, you get whatever last was pushed, which is what you're referring to. And then within a scope of a name and no tag, you can reference the SHA-256 digest of that exact same thing. So any Docker file or even fetching, you can do like at SHA-256 : blah, and that base image will be the exact build that you need.
Right, but you're pulling it from Docker Hub. Do you have accountability of what is inside that base image?
Yeah, so it's effectively a Merkle tree of the config of that image, all the layers, accountability. You could get into like signing and all this kind of stuff, but if anything changes in any of those tar archives or config, the digest would be different.
So,
it is a full cascading hash.
So I understand that that's the case with the whole container image, but the thing with the container images is that, like the gentleman said, it's built on top of other container images, and you don't have any of that information.
That's not necessarily true per se. So when you're building up your layers, so you've got multiple steps in your Docker file, or you look at the original manifest from, say, Alpine, or let's just take CoreOS or any other group that's building on top of base images. Every time they go and build it, so all their dependencies and all the aptitude, like your Yum aptitude packages they're building up in that space, or you're in Alpine space, each layer will have a 256 digest. So you can pull each layer as it was actually being built. The context is if I run it a week from now and there's been an update to a dependency package that I was using, say Python released a new version or update, it will have a different SHA. And again, you've got the full collision space or the entropy of SHA. So the idea of I ran it a week later and it generated the same SHA, I don't know, is there any statistics or mathematicians in here that can give me the odds of that? Like, not to say it's impossible, but I'd say it's improbable.
Okay, so what I am so what I'm trying to do, like the whole exercise where we stepped back and talked about the unit of a build, the issue with pulling down the whole container image or building on top of a container image for which you just know the digest of that container image, is that that unit is lost. So now the way that you're referencing that artifact is via one digest. But what's inside the artifact is a whole host of packages for which you don't have any of that other metadata.
Can I follow up on that?
Yes, go ahead.
I think you're precisely on point. I also work in the reproducible builds project, and Debian is not 100% reproducible. So even if you want to build the same Debian image, you will not get the same packages out for certain packages that are not reproducible. And that's a problem when you want to guarantee auditability properties or bit-by-bit reproducibility on your base Debian image, for example. I don't know the statistics for other Debian distribution for other Linux distributions, but this can happen. I'm sorry.
It's the same.
It's yeah. I mean, I don't.
Some projects like Nix have gotten close, but through creative processes, it's a difficult problem.
Right.
Yeah, so I mean, the issue here is right up to the base OS image layer, it is a difficult problem. And what you're doing is basically saying, okay, I trust the provider of this operating system to give me all of this metadata, the information that we had listed before. And so if the whole idea of trust is that, you know, you're taking care of me, I don't have to ask you any questions. I don't have to query your packages. I just know it's good. Oh, there's a person at the back, sorry. It's fine.
Oh yeah, I was just jumping off this conversation. So like right now, the granularity of the digest is at the layer level.
Yeah.
The next step to make it more reproducible, or at least do better diffs and more better cacheability, would be to actually make it a per file digest, and that will give you kind of what you're talking about. Now you can take an RPM and you can unpack that and you can digest each file in that and then verify it against what the contents of the container image.
Yeah. The thing go ahead.
Yeah, so on that point, so tar archives have been great and terrible, but there's already some discussion going on within the OCI community of a potential V2 image format that would flatten out and not do per tar archive, so that you could have not only better deduplication on the registry and on disk, but you could see like per file diffs easier, like more self-expressing and more cacheable per file or even per chunk.
Are we out of time? Oh, 2 more minutes.
Oh,
okay.
Okay, quick.
All right, I'll go quick. 2 things I wanted to mention. One thing for some of the base image issues, one of the things that Google has been working on is this notion of distrless images, which are basically Scratch with just standard libraries, and they work for certain languages. And then you come with the packages you need to install, and you need to figure out how to get those. So there's the issue of how do you build these packages or install them in a reproducible way, but that's one thing. And then a tool that I think is missing from here that is kind of coming is Bazel, which has rules to be able to build Docker images in a reproducible way without, in a declarative way as well. And so there's certainly some things missing from that. It's still, being worked on, still being improved, but I think that's another tool might be worth putting on this table and looking at.
Build Kit, Linux Kit, all of these address some of the issues, just not all of the issues. And I'm just trying to figure out whether there's any movement forward to address all of the issues. I just have one more question to ask. So in Habitat, there's a thing called a heart file, and that's basically a tarball with metadata attached, specifically the checksum of the tarball. That seems interesting to me because it actually does take that unit of the build and attaches the metadata to that. And so when you're distributing it, the metadata goes along with that build unit. So even in a container space, that still seems to be something that you can query because it comes with a tarball. So I don't know what your thoughts are on that.
So one other thing I wanted to comment on is one of the things we're struggling with right now, and everybody should be, is GPL license requires the source of the builds to be revealed. and there's nothing in the metadata that tells you where these things were created from.
Yep.
If they came from something other than, RPMs or apt-gets or something like that, because the distributions currently cover this, but people putting random content in is not following GPL, and that's to me is
Yeah.
a potential
I'm
real
going to
problem.
plug in that project again, Turn, that's supposed to take care of or supposed to tackle that problem. But it really would be much easier if we just had all of this information in the artifacts we're distributing. Okay, I think I'm out of time.
Well, thank you.
Thanks a lot. I'm around so you can talk to me, argue with me.